Good morning, everyone. Welcome to today's hearing. Today we're going to begin by hearing evidence from a representative of the company that made the dampers that were used in the refurbishment of the smoke control system. Yes, Mr. Eustace.
Can we please call Mr. Roy Jones?
Thank you. Good morning, Mr. Jones.
Good morning.
I gather you're going to make the oath.
Yes.
So you take the book in your right hand, if you would please, and read the words on the screen.
I swear by Almighty God that the evidence I shall give shall be the truth, the whole truth, and nothing but the truth.
Thank you very much. Would you like to sit down then and make yourself comfortable?
Thank you.
Thank you, Mr. Jones.
Thank you.
Can you please,
All right. Yes.
can you please give the inquiry your full name?
Yeah, Roy George John Jones.
Thank you very much for coming to give evidence today and to assist the inquiry with its investigations. I will be asking you questions today. If you have any difficulty understanding or hearing what I'm saying, please do ask me to say it again. And if you'd like me to rephrase the question, please say that as well. If you feel that you need a break in addition to the one we usually take at about 11:15 in the morning, please let us know as well. And if you could also please keep your voice up so the transcriber sitting to your right can hear and also keep up. So if we take it a little more slowly. You made a witness statement to the inquiry. Can I take you to it, please?
Yes.
It's GBL 6010. And that's your name there. And if we scroll through to page 7, please. That's a statement dated 31st of October 2019. Is that your signature, Mr. Jones?
It is.
Have you read your statement recently?
I have.
Can you confirm that the contents are true to the best of your knowledge and belief?
They are, yes.
Have you discussed your evidence with anyone before coming here today?
No.
Thank you. First, I'd like to ask some questions about you and your background and qualifications. Do you hold any qualifications in relation to manufacture and use of dampers, please?
Not specifically, no.
And what training have you had in relation to dampers and their use in smoke control systems?
None.
You mentioned in answer to my earlier question, not specifically, are there any more general qualifications you hold which you think might be relevant to dampers?
I've been involved with various committees in relation to dampers, the Smoke Control Association, typically one of those. I am also part of the FSH 22-4 BSI committee. It hasn't sat for a decent while, but that's on dampers in relation to forming the European standards for damper products. So I do sit on those committees, but I'm not active on any of the committees that are present.
You mentioned the Smoke Control Association. Let's take that one first.
Sure.
How did you come to be on that committee or on the association, in the association, I should say?
The company as a whole has been involved prior to my involvement. My previous boss, my previous director, was on the Smoke Control Committee. When he retired, I stepped into his shoes and moved into that position.
So is that a membership which attaches to Gilberts as a company and they send someone they choose, or does is there a selection from the SCA?
Yes, no, the Smoke Control Association is open to send a member from a company. So it's the FETA membership, FETA are the controlling body under HEVAC, and the Smoke Control Association is one of the associations in there. You don't have to apply to attend, you can just attend as a committee member.
You also mentioned the BSI Committee on Dampers, which doesn't sit at the moment. Can you tell us a little more about that? And again, how did you come to be on that committee, first of all?
Same thing again. My predecessor had been on those committees, and I had to apply then to be on the committee in writing with a letter to state my credentials, my experience, and why I could offer help to the committee in regards to forming European standards. So I did that, and at the same time the RHE2 committee, at the same time the two committees running concurrently, if you will.
I will be asking you and taking you to numerous BSEN documents today. Is it fair to assume that you will be familiar with any to do with dampers?
Yes, yeah, and if I'm not, I'll let you know.
Thank you. If we can please go to paragraph 2 of Mr. Jones's statement. And just to summarize, here you tell us that in October 2019, when the statement was made, you were the Gilberts technical director and have been employed in that capacity for about 4 years at that point, yes?
That's correct.
A little about Gilberts first. Does Gilberts specialize in the supply of dampers for smoke control systems?
No.
And what is it that it does, if you had to describe it in a sentence?
Gilberts, in relation to dampers only, 10% of Gilberts' business is in supplying the dampers. The dampers that they supply in this instance are smoke evacuation dampers. And we also supply, by factored goods, some smoke fire dampers and fire curtain dampers.
Does Gilberts design any dampers?
Yes. We designed the Series 54 damper.
Yes. And in due course, we'll come to the testing documents for those. But in terms of the design versus the supply or manufacture, what share of the business would you say that is?
Sorry, could you repeat the question?
Let me rephrase it. Your role at Gilberts,
Yes.
You're technical director.
Yes.
To what extent does that deal with design of dampers?
Sure. I have an R&D team below me. We have an external consultant and an R&D test facility. And we detail and manufacture from scratch products as requested and as needed in the marketplace.
So you said in your statement you were with Gilberts 4 years as a technical director. Were you with the company before then in a different capacity?
Yes.
And what was that?
Sorry. I've been there since I was an apprentice when I was 17. So I've worked my way through the company up to the technical directorship.
And what was your role just before the technical director?
I was senior technical manager.
And just help us with this, how would you describe Gilbert's business overall?
Overall, our core business is grills and diffusers, supply of grills and diffusers. The products you see in the ceiling, letting the air into the room, if you will. That's around 50% of our business. We then have different sectors, one of which is a fire smoke sector, which is around the 10% of our business.
Thank you. Yes, it is.
And thank you, Mr. Chairman. In your roles as senior technical manager and then technical director, were you attached to either of these teams, the 50% grills and diffusers or the 10% smoke, fire and smoke?
All, in both positions. I was involved with both of those.
So overall, what is your experience in relation to dampers or smoke control systems?
I have a general overview, which is helped by attending the committee meetings to be able to understand the needs and relevance of various product and systems that exist. This then helps ourselves as a company to hopefully help the industry provide a product that's suitable and tested to the correct standard for the marketplace.
Are you able to assist, as far as supply of dampers is concerned, how much of that, what share of that goes to residential, for deployment in high-rise residential buildings?
We don't keep a track on that specifically. There are a lot, whether it be high-rise residential or commercial buildings. I would assume the majority would be high-rise residential, but we wouldn't know whether they were 3 floors, 10 floors, 18 floors, etc. We don't get involved in the detailed design of the smoke control systems. We just provide the dampers.
So you may have answered my next question just now, but in the supply of dampers, have you done so in relation to pressure differential smoke control systems?
The dampers we provide are smoke evacuation dampers, marketed as such and provided for that purpose. I'm not aware of any system, be it, as previously noted, as push-pull, pressurised differential, etc. These are all common types of system that I'm aware of, but we're not aware at the time of supply what the system is behind the product in use.
Thank you. So next, I'm going to ask you just some for you, given your expertise, very basic questions about dampers to assist us to understand the various components. If I can ask to turn up page 296 of Dr. Lane's smoke control report, which is BLARP 25035. That's page 296, please. Thank you. And may we zoom in on the figure at the bottom? Right, Mr. Jones, can you see that?
Yes.
No. So we're looking at, this is a post-fire photograph of Gilbert Series 54 damper. And if we look at the picture on the left, please, are the dampers the two metal plates we see in the open or horizontal position on this picture?
Yes, that's the damper, yes. The damper blades, yes.
Also known as blades, yes. And is it right that in very general terms, the purpose of dampers is to regulate airflow, so letting in or keeping out air which travels through the shaft which is situated behind that damper?
In the case of the smoke evacuation damper, there's two functions. The first one is to either seal the shaft on a non-fire floor or to open to evacuate the smoke into the shaft on a fire floor.
Thank you. And we will get to the smoke evacuation dampers in due course, but that's very helpful. The photograph on the right, that shows another side of the same type of dampers, but in closed position. Is that right?
That's correct.
Do you recognize the dampers on these pictures as the Series 54 Gilberts dampers?
Yes.
Is it right that these dampers are opened and closed by an electric motor called the actuator?
That's correct.
And the process of opening or shutting the damper, it's not immediate, it doesn't snap shut, it takes a matter of some seconds.
Yes, the full cycle is less than 1 minute from full open to full closed.
Thank you. If you look at the right side picture and look at the bottom right of that picture just above the date stamp, is that an actuator connected to the damper?
That's correct, yes.
If we turn over the page, please, so that's page 297, and look at figure 7-39 at the bottom, so zooming in, please. Thank you. This is a close-up of an orange device, and I can see on my screen the words, is it Balimo or Belimo?
Belimo is the way
Belimo,
it's normally pronounced.
in
Yes.
black lettering. Do you recognize this as a Belimo actuator supplied with a Series 54?
Correct, that's right.
And again, in general terms, can we agree that where smoke is traveling through the shaft, the damper is all that or the shut damper is all that stands between it and the compartment on the other side?
Yes, yes,
And so it has a very important safety function to perform, in summary.
yes.
Next, I'm going to ask you about categories or types of certified dampers with reference to a table produced by Dr. Lane, which we can find in BLARP 2, 5035, page 94. Looking at the columns, so this table is titled The Three Types of Dampers and the Key Test Conditions Leading to Classification and Differentiation. Looking at the columns at the top, starting with fire damper, we can see fire and smoke damper and smoke control damper. Do you see that?
Yes.
Can you explain in simple terms, please, what the differences between those are?
Yes, the fire damper is traditionally a fire separating element, either through a wall or a duct. What it does is it would normally have a fusible link that would then close when it was warm, i.e. sensed that there was heat travelling through the duct. It would operate closed in that position, therefore stopping the fire spreading further, thus performing compartmentation, either between rooms or ductwork.
Sorry, just to interrupt you. When you say it has a fusible link,
Yes, sorry.
would it be right to understand that the link, as it were, operates and the damper then closes what, by springs, or is
Yes.
it actuated?
By springs, yes. That would be normal. You could use the term fire damper for a motorised fire damper, so you could have a motor connected to it. The traditional way of a fire damper would be a spring-loaded thermal fused fire damper.
Yeah. Thank you.
But as I say, it can be construed the other way. But that's its main purpose. So the fire damper is a simple curtain, closes on heat activation and shuts. The fire smoke damper is a damper that's designed to stop the fire and the smoke at that point, so it has a better seal. So with the fire and smoke damper, these are usually actuated with a actuator, a motor, to be able to close the product once the heat or temperature was sensed through a thermal fuse, or possibly by a building management control system or a smoke control system that's detected a fire somewhere else. And it would then close and again compartment those positions within the building, either again wall or duct. And then finally, the smoke control duct. The smoke control duct itself is very similar to the fire and smoke damper, apart from the fact that it's further developed and tested to be able to open and close during its operation, to be able to manage the smoke throughout the building. So as the fire continues, the damper could be used either to evacuate through the actual damper itself, rather than just close and compartment.
Thank you. That's very helpful. Just picking up on a term you mentioned, fusible link. Is that an alloy that melts at a particular temperature and effectively triggers?
It is, yes. It's normally like a strip with some solder, a copper strip with some solder. And what happens is at about 78 degrees, the temperature would then melt the solder, the two parts of the copper would fall, and the blades of the carriage would fall and form a barrier.
So unlike in the actuator-controlled smoke control damper or fire and smoke damper or smoke control damper, you don't need a signal from another system?
No, correct. It's standalone.
And while we're on this, can you just explain what affects the quality of the seal in the different sorts of dampers? Because you said that the fire and smoke damper has a better seal than the fire damper, I think.
Yes, the fire damper would be tested to stop the fire, so therefore it has to have an integrity leakage. The integrity leakage is noted as 360 metres cubed per hour per metre squared. So that's what that has to achieve to be called a fire damper, if you will. The fire and smoke, what they do, because you want to stop fire and smoke at that point, they restrict that amount, so it has to seal better, down to 200 metres cubed per hour.
But what actually affects the quality of the seal?
The quality of the product in relation to a dovetail is usually used for the blade, where you would have a dovetail come across the back of the blade as it closes to give a proper seal, blade against blade, whereas the curtain damp has to be a flexible product that would drop into position.
Thank you.
Thank
Sorry
you,
to
Mr.
keep
Chairman.
interrupting.
Not at all. It's all very interesting stuff. So you've described different functions and different requirements. So is it right that, broadly speaking, there's a hierarchy, fire damper at the bottom with the least onerous requirements, fire and smoke in the middle, smoke control damper at the very top in terms of requirements and
Yes, and
specialist
testing of
use?
those. Yes, yeah, generally.
Mr. Jones, I'm sorry. The transcriber will have some difficulty in recording if we talk over each other. So if we could both please wait to finish and then speak. Thank you.
It's a very difficult job transcribing these sort of questions and answers, because there's a natural tendency on the part of the witness to cooperate by giving the answer very quickly, and a certain enthusiasm on the part of counsel to get to the next question. So you can both wait for the appropriate opportunity. Thanks.
Thank you.
Thank you, Mr. Chairman. So we will look at the regulatory background of all three dampers in more detail. But first, do you agree that the first two, so the fire and smoke dampers, are defined in approved document B 2013?
That's the definitions are there. I think they're taken from the approved document B.
Yes, and we'll come to look at that in due course. And then the third type, smoke control dampers. Can we please go to RBK 3045054? We can see the BSEN 12101-6 2005 there. I take it from your silence that you are familiar with this one as well.
I'm familiar, but I don't use this in any of my work moving forward as such.
I see, thank you. Can we please turn to page 71 and focus on clauses 11.8.29, so that a bit toward the bottom of the page. In fact, I think we can probably see it as it is. Fire dampers shall not be used in pressure differential system supplied ductwork. If such ductwork penetrates a fire-resisting compartment, the ductwork shall be protected with a suitable fire-resisting material. And 11.8.2.10, if different pressurized or depressurized zones are connected to the same fan or set of fans by a common system of ductwork and or shafts, smoke control dampers shall be used. Are you familiar with that particular requirement?
In general terms, yes.
Can we agree then that this British standards effectively says that only smoke control dampers, not the other two types of dampers, should be used in systems matching that description.
No. The standard doesn't advise for the product that's produced or provided in this instance.
Just to elaborate on that, are you saying that it doesn't define what a smoke damper is?
Sorry, so the standard here is saying, sorry, I just need to reread that a second. Yeah, the standard is asking for a common system of ductwork and/or shafts for smoke control dampers. Yes, it is asking for that. Sorry.
Yes, thank you very much. So we will delve into the exciting documentation around each type of damper, but we'll take them on turn by turn. So starting with fire dampers, we'll go through both the testing and the requirements. So first of all, fire dampers. Can we look, please, at, again, back to approved document B 2013 for the definition of what a fire damper is, which is CLG 50224, page 144. If we could zoom in on the top two entries in the right column, please. So we'll look at the fire and smoke damper definition shortly, but focusing on the fire damper now. Mechanical or intumescent, just because it's something I had to look up, I'm going to ask you, Mr. Jones, so we can exclude it from our consideration. That's something that expands with temperature, effectively, is that?
That's correct. So instead of having a fusible link, what you have is a material that will expand on temperature, traditionally used sometimes in ductwork, mainly in doorways, to be able to block an opening.
So we're looking at mechanical then. Mechanical device within a duct or ventilation opening which is operated automatically and is designed to prevent the passage of fire and which is capable of achieving an integrity E, we will be coming back to these letters quite a lot, classification and or an ES classification to BSEN 135013-2005. So that's the classification standard.
Yes, it is.
When tested to BSEN 1366-2-1999, and that's the testing standard.
Correct.
Thank you. Can we please go to Dr. Lane's Phase 2 Smoke Control Report, which is BLARP 25035, page 86. And looking at the last paragraph there, if we could just blow it up slightly, please. Do take a second to read through that, but to summarize, Dr. Lane says that the purpose of a fire damper is to close and remain closed during the fire, preventing the passage of fire, which is, I think, what you said when giving the description in the beginning, yes?
Yes.
So you agree with that?
Yes.
And it's required by ADB 2013 to protect openings created by ventilation systems in internal compartmentation. Is that also, do you agree with that as well?
I agree with the definition. The only caveat I would put on that is that the internal compartmentation doesn't actually mention a shaft, so it doesn't actually appropriate towards a shaft itself. That's dealt with somewhere else.
See, thank you, that's helpful. Can we, I do apologize to the operator for lots of jumping back and forth, but back to the ADB, page 88 this time. So that's CL, in fact, you've got it there. So it's middle of the right column, we see what performance has to be shown in terms of minutes. Fire dampers should be tested, and we've been through this, I won't repeat it again, it's the classification and testing standard. They should have an E classification equal to or greater than 60 minutes. Fire and smoke dampers should be tested, same standards, but they should have an ES classification equal to or greater than 60 minutes. So, given your expertise, you can no doubt tell us, what, in simple terms, what an ES classification is.
Sure. The E's integrity, that means that it matched the 360 metres cube per hour leakage rate required of it, and the ES is that it's reached the 200 metres cube with more onerous 200 metres cube, so less leakage if it has an ES against an E.
Thank you. That's very helpful. In fact, we'll just for the transcript look at the definitions of integrity and smoke leakage on page 9, please. In fact, it's a new BSI. BSI 50810 So fire classification of construction products and building elements, it is a bit of a wordy one. Classification using data from fire-resistant tests on products and elements used in building services, installations, fire-resisting ducts, and fire dampers. And if we could turn to page 9, please. Section 5.1.2 is an explanation of what integrity E means. It's the ability of a component of a service installation to prevent the transmission of fire as a result of the passage of significant quantities of flames or hot gases from the fire to the unexposed side, thereby causing ignition either of the non-fire exposed surface or any material adjacent to the surface. Would it be fair to summarize that as effectively a characteristic which assesses how good the damper is at preventing actual ignition of material on the other side?
Yes, that's correct.
So it's not about the volume of smoke leakage. And if we turn over to page 10, please. And that's the 5.1.4 smoke leakage. So similar, definition of a similar type, but for the smoke leakage, the ability of the component to resist the passage of gases or smoke at ambient temperature and during exposure to the standard temperature time test. The leakage rate is corrected to 20 Celsius. So that involves two elements, doesn't it? Ambient temperature and a heated test.
Yes.
And this smoke leakage measure is about limiting, unlike the integrity, the volume of smoke going through the damper.
Yes, that's correct. The integrity leakage is as well, as I say, at a certain limit you must have to achieve integrity with the product.
Yes, you mentioned we'll look at, in fact, we'll look next at the numbers, but broadly you said 360 for the integrity, 200
for the smoke.
and I'm purposefully not mentioning the units because I was very much hoping you would pronounce it for me first, Mr. Jones. So, in fact, I'm going to ask you about that now. If we can go to BSI 50829, please, page 1. Fire-resistant tests for service installations, Part 2, fire dampers. Is it right that this is the relevant test standards as we've seen for both fire and smoke dampers?
That's correct. And for smoke control dampers as well.
I see. Well, we will get to that in due course. But staying with the performance criteria for fire dampers for the minute, can we turn to page 16, please? It's the performance criteria box at the bottom. The following performance criteria apply after 5 minutes from the start of the fire test. And turning over the page, please. And we see there under integrity, and there's a figure and a unit. The best I could come up with is cubic meters per square meter hour. Is this
Close. Meters cubed per hour per meter squared.
meters cubed? Thank you. And we see the measure there. After the start of the fire test, the leakage through the fire damper shall not exceed 360 of that unit. And the integrity will be judged according to a different set of criteria, which I don't think we need to go into just now. There is a helpful note. So after C, the result of the fire test shall be stated in terms of the time elapsed to the completed minute from the commencement of the heating to the time when the fire damper failed to satisfy the criteria for integrity, insulation, or leakage, or the termination of the heating, whichever is the shortest. So we see this expressed in, for example, E60, ES60. So that's how long did it meet that particular code?
Absolutely correct. And within the fire test itself, you will find that the test may have run in the instance of the 54, maybe 74 minutes. The classification document, the 13501-3, only allows you to classify in half-an-hour slots. So therefore, you claim an E60 at that point or an ES60, depending on how it was tested.
Thank you. We'll now turn to fire and smoke dampers, please. And we're going to go back to approved document B for the definition, which is at CLG 50224, page 144, just below where we saw the definition for the fire damper. So, in fact, I don't think we need to take it at any length because you've effectively explained to us, but it's the same test standard, the same classification standard. But we'll see there's, as we've seen, there's a different requirement. Is that right?
That's correct.
Dr. Lane, and I won't take you to the page, but I'll summarize what she says. She explains the purpose of this type of damper as to close and remain closed during a fire, where air handling ducts pass through fire-separating elements, protecting an escape route. Do you agree with that?
Yes.
So, effectively, it means it's still one that stays closed, doesn't close and open during the fire.
Correct.
And do you agree that the AS classification means that we've added on the smoke leakage? That's the AS.
Yes.
If we go back to the classification standard, please, which is BSI 50810, page 16. There's a table there that you may be able to assist us with. So the introduction says, for dampers for which the AS class is relevant to the leakage through the fire damper shall not exceed 200 meters cubed per meter squared hour. And below we see the different categories and the corresponding numbers. So for E, we see 360. The next row shows ES. So both, if we look down at the column numbers or column titles, both leakage at ambient temperature and during the fire test is 200.
That's correct.
And last reference to ADB for now, paragraph 5.48, page 61, please. We're looking at the top paragraph, 5.48, and the note specifically in bold under it. Fire dampers activated only by fusible links are not suitable for protecting escape routes. So those are the non-actuator dampers, yes?
Yes.
However, an ES classified fire and smoke damper, which is activated by a suitable fire detection system, may be used. So is that saying effectively, as long as your damper is ES classified, it's a fire and smoke damper, and it's operated by an actuator connected to a system, according to this document, in any event, it can be used for as an escape route protection?
Yes, I think it's basically saying that it's got to be part of a system. It's not a standalone damper.
And the reason, as best you can help with this, for why there's an additional AS requirement in the context of protecting a smoke, an escape route, is because it's not just fire that's dangerous, it's also if the space, a corridor, a lobby or a stair is logged with smoke as well.
Yes, the smoke classification is that if there is a smoke on one side, you don't want it to pass through to the other side as well. Hence the higher leakage requirement, therefore leaking less smoke from compartment to compartment.
Thank you, that's very helpful. Turning lastly to smoke control dampers, can we please go to the front page of test standard 1366-10, part 10, which is BSI 30177. So this is the BSEN, so effectively it originates in the European sphere, does it?
Yes.
But that has to be adopted in, or at the time in any event, had to be adopted in this country.
It's a slightly longer story than that. We start with BS standards in this country, and when we joined the European Union, we then collaborated to then make EN standards. So we all throw our own standards, our own national standards together, and then they became EN standards when they were harmonised, so that everyone across Europe could follow the same standard. So any BS standard that exists still today is still called a national or a local standard, and any EN standard is adopted across Europe.
Thank you, that's very helpful. And I know we'll turn to some questions around that as well, so you'll have a chance to explain in a bit more detail. But if I can ask to turn to page 12, please. And these are the defined terms for the purposes of the BSEN. 3.27, we see smoke control damper, a device that automatically or manually activated, which can be open or closed in its operational position to control the flow of smoke and hot gases into, from, or within a duct. Do you agree that the primary functional difference between these smoke control dampers and the ones we discussed is they must be capable of opening and closing in the course of a fire?
In this definition, yes.
You say this definition. Is there another definition of a smoke control damper?
Well, it's saying that it must be open or closed, because that's what the function of the product is, that it would be able to adjust the air path or the smoke path to evacuate the smoke out of a building in the best possible manner. There are times the smoke control damper may not necessarily need to be, because it will be designed to be in the closed or go to a closed position rather than be opened at a later date. It will be just a safety device at that point, but it would still be a smoke control damper that would be used in that system, whereas they could have possibly used a fire smoke damper, for instance.
But the key to the identity of a smoke control damper is that it can move during
It can adjust.
operation,
It can adjust,
so to
yes.
speak.
Yes, sorry.
It can be moved open or closed depending on what you need at any particular moment.
That's what that says in this context, yes, sorry.
Thank you, Mr. Chairman. We'll now look at the classification standard for smoke control dampers. If we can turn to BSI 6048, first page, please. So it says smoke and heat control system smoke control dampers. If we can turn to page 18, please. And look at section, zoom in on the top half, please. This will take just a minute to read through, but it's significant. It sets out the integrity performance requirements for smoke dampers. The assessment of integrity, E, of multi-compartment smoke control dampers as one of the fire-resisting performance characteristics shall be made on the basis of A, leakage through the damper at ambient and when closed. When it says at ambient, it almost calls for a word there, such as temperature. Is that temperature is what it's intended there?
Yeah, as before, it's temperature corrected to 20 degrees, was what ambient would be classed as. So it should be tested at 20 degrees Celsius or corrected for that.
See. So where we say leakage through the damper at ambient, that should be ambient. It refers to temperature.
Yes.
Yeah. And when closed after 5 minutes, automatic operation, or 30 minutes, systems with manual intervention, we'll come back to that later, from the start of the fire test. B, the ability of the damper to maintain its opening when subjected to the fire test. C, cracks or openings in excess of given dimensions and ignition of a cotton pad and sustained flaming on a non-exposed side at the perimeter of the damper junction with the wall or floor of the duct, the penetration. So that's quite a technical testing methodology. The reference to ignition of a cotton pad.
The test is exactly the same as under the 1366-2 testing. There's nothing different. It's characterising it here rather than setting a new standard. You still use the same 1366-2 test, and it has the cotton pad, it has the leakage criteria, etc. within there.
Yes, thank you. And lastly, D, the suitability for use of the damper at under pressure measured at ambient. Looking at these requirements, do you agree that two of them, the A, leakage, and C, cracks requirement, as you just said, are the same as for a fire damper or a fire and smoke damper, but B and D are different?
Yes to the first part, B and D are different. Yes. The suggestion here, or what it's detailing here, is the fact that the damper could be opened during a fire test, rather than every other fire test where you would normally have the damper in a closed position. So that's what the B part's explaining there.
And one of the key differences is the use under pressure, because we've seen about 10 or 15 minutes ago when I referred to the pressure differential system paragraphs, that these smoke control dampers are often used in that context.
Yeah, the 13662 test, which all the dampers are tested under, are all subject to a 300 pascals pull force on the damper itself during the testing. So the furnace is lit, the time temperature curve increases at the rear of the product, and on the front there's a plenum which draws 300 pascals constantly across the damper during the test. When it's talking about the ambient test, you haven't put the furnace on at that time, and you do the same thing. You pull 300 pascals across and find out what it leaks before it would be subjected to any temperature.
Thank you. We'll come back to the pressure, operating pressure factors in a few minutes. Can I ask?
Sorry, can I
Yes.
just clarify my understanding of something? You talk about pulling a certain pressure across the damper.
Yes.
Is this in the direction that would tend to open it, I assume, is it? Because the way the damper works, you've got vanes which, if pressurised on one side, would force them closed, but if pressurised on the other side, would force them open.
Yes, if you had that such of a damper, you would have to test the damper twice. You'd have to do both sides. You'd have to turn it around and test it. If you claim symmetry for the product, i.e. the damper blades would fishtail and dovetail in the centre of the product, then whichever way you pulled or pushed, you could define that you'd only need the one test to be able to classify that product.
Yeah. Thank you. Yes,
Thank you, Mr. Chairman. Dr. Lane, in her report, derives the actual numeric performance criteria for a smoke control damper, but just to see if we can agree it without having to go to all the documents. She says that the smoke leakage performance, where required for a smoke control damper, is 200 cubic meters per square meter hour. Do you agree with that?
That's correct, yes.
And that's, in fact, the same as it is for a fire and smoke damper.
Yes.
Thank you. Can we please turn to Dr. Lane's report, which is BLARP 25035 at page 92? It's BLARP 25035 at page 92. Thank you. Looking down at the page at 4.8.70, so you've confirmed that it's the same numeric criterion, but Dr. Lane here sets out what the test differences are. She says, that, and we can see that it's important to note the test method for evaluating both integrity and performance and smoke leakage performance is different. The key differences are as follows. Over the page, please. If we could zoom in slightly, please, at the top. Just to summarize that, the number of open and closed cycles, so the operation reliability testing, it's 10,200 cycles prior to testing, the fire testing for smoke control dampers, versus just 50 for fire dampers and for fire and smoke dampers. Do you agree with that?
Absolutely correct. The only thing is, obviously, if it's a fire damper, it doesn't go through cycles because it's not motorised. It's a fusible link product. But yes, the essence is that the smoke damper does go through an extensive number of cycles, other than the just standard fire and smoke damper.
And that's because, as we've discussed, it's designed to open and open and close repeatedly.
Not specifically, no. The damper itself is tested for 10,000 cycles, so that during the lifetime of its operation it can be proven that it would operate at any time, because the damper may even sit dormant for 10, 20, 30 years. But when there's a fire within that building, it must operate immediately as designed. Yes. So there would be weekly tests or anything on the damper during that time, and therefore wear on the product. So it's to define, in my understanding, is to define that after 10,000 cycles, the product would still operate and still be a fire-safe design product.
Thank you, that's helpful. And in some systems, would you accept where there's a combined environmental and fire smoke control system, where the dampers are used for both, they may be opening and closing as part of the environmental function on a daily basis?
Yes, that isn't, as far as I'm aware, why this part of the test standard is here.
I see.
As a manufacturer, what we would do is we would do our own longevity test for the product and cycle it as many times until it broke as such, and then claim that as our a number of cycles.
Thank you. That's very helpful. And the second difference is the ability of the damper to change from open to closed position and vice versa at elevated temperatures. Do you agree with that difference as well? And the reason...
Sorry.
If you need a second to...
Did you want the witness to respond to that question?
Yes, please.
Yes. Can you remember the question, Mr.
Yes, no, sorry, I can. I'm just rereading it. Sorry.
No, it's all right.
My apologies.
Read.
So it's defining here that the smoke control damper can change from the open to a closed position. Within the testing standards, there are certain criteria that you have to hit, and there are certain criteria that you don't have to hit. And the HOP 430 test is optional in relation to whether you wanted to test to allow the damper to open and close at this situation.
In a system where there's an option, as we've seen, there were 2 periods for automatic use and for manual use. The latter was, I believe, up to 30 minutes from the start. In a system where there's a manual intervention option, so a firefighter turning an override key on the floor or using the a panel for the system to change the level of operation, that could involve a smoke control damper coming into effect later on in the process, yes?
Yes, and I agree. Sorry, I know where you're coming from now. Sorry. Yes, the damper would have to have been tested with this part in there to be able to open and close after the fire incident. Thank you.
So in addition to those differences, you've touched on the Pascal pressure difference in different testing standards. I'm going to look at that in a little more detail, although briefly, hopefully. If we can turn to BSI 40177, please, at page 16. And zoom in at the top, please. So you mentioned that under the BSEN 13662 test for fire and smoke dampers, it's 300 pascals. Yes.
That's the standard definition we use on the fire damper side. What you have here is a list of options that you could test the product to. And certain other standards like the classification standard, the 12101 Part 8 standard that was referred to previously, will actually determine that to be classified as a certain product, it would have to be at least pressure level 2, for instance, which would be a smoke control damper.
And we see in the second column operating differential pressure at ambient temperature. Does the selection of the testing pressure, would that depend on what pressure is used in the system you're putting the damper in?
Yes. In essence, if you were only ever going to operate the duct system below 500 pascals, you could then use the operating different pressure level 1.
And foreshadowing slightly the more detailed evidence on testing we'll go through, were the Gilberts Series 54 tested at the higher pressure differential we see here of 500?
No, the Series 54 damper underwent a 13662 test. It was at the minus 300 pascals pressure differential test, and the smoke leakage test was at 1,000 pascals. So it was a classification 2 test.
Thank you. Turning to Gilbert Series 54 itself, before we dive into the technical detail, can you explain, please, which type of damper did you consider it? Did you consider it to be a fire damper, fire and smoke damper, smoke control damper, or some other damper?
Some other damper. The damper itself is a smoke evacuation damper, which doesn't fall into any of those 3 categories.
I will ask you about that in a bit more detail, but just for a visual, if we can please turn to the 2011 brochure from your company, which is PSB 50201, first page. Thank you. And we see which there, it's a October 2011 brochure, top right, under the title of Series 54, we have smoke evacuation damper. Can you explain, please, what smoke evacuation damper is and where the term comes from?
Yeah, it's a damper that's been designed just simply to evacuate the smoke from lobbies or areas that may be affected by smoke, to clear passageways and allow the passage of smoke through the damper and out, usually through either a natural or an active fan-assisted shaft. That was where the product was born from, if you will.
And does the term smoke evacuation damper, as far as you know, appear in any of the guidance documents, approved document B, BSENs, or British standards?
No, it doesn't. Not that I'm aware of, sorry.
Is this an industry term or a term that Gilberts coined or uses?
We've used it extensively from the inception of the product. And it clearly defines what the objective of the product is, hopefully. It's not exclusive to us, but I couldn't say whether we're the first to use it or not.
Can you assist us with this? Typically, to the best of your knowledge, what type of system would a smoke evacuation damper be compatible or be appropriate for?
Yeah, as I say, the product was designed in mind to have a smoke shaft, as I say, either natural or passive. The reason for the product to exist was we were approached to be able to produce a damper which would achieve a 1.5 metres squared geometric free area, yet still be able to pass a rigorous fire test. We were asked if we could do this. We took up the challenge and produced this product.
Thank you. Can we please go to page 2 and zoom in on the middle of the left column? And we see there, it's the second paragraph on the left, a multi-parallel linked blade smoke damper in the Series 54 is manufactured from robust 1.5 millimeter galvanized steel and is fully tested to the requirements of EN 1366 Part 2 for 1 hour. Usefully, the damper combines both a low leakage rate when closed with a high, as you said just now, high free area when open to support high smoke evacuation rates. So would you agree that, and I think you will based on what you've said so far, that nothing in that description suggests a smoke control damper or intended to be one?
Absolutely correct.
And it doesn't cite, for example, BSEN 1366 STAN, which is the standard for smoke control dampers.
Correct.
We'll now look at the specific supply of dampers for the Grenfell Tower project. Starting with the level of information Gilberts had, and I appreciate you, as I understand it, you weren't involved in this transaction, is that right?
I wasn't particularly, but I know the company details researched and provided that evidence already.
I will summarize, hopefully fairly, paragraphs 5 and 6 of your witness statement, which for the transcript. You say that Gilberts was not directly involved in the Grenfell Tower work, but supplied to J.S. Wright 80 Series 54 dampers in 2 sizes on 5th of June 2015, and then a further 8 in November 2015.
That's correct.
Thank you. And you say that Gilberts had no involvement or input in the smoke control system project, yes?
Correct.
Is that a fair summary of
yes, yes. That's what I've written.
Is it therefore your evidence that Gilberts was not asked to provide any advice on the selection of appropriate dampers for this system?
Absolutely correct.
And did it provide any advice?
No.
You also say at paragraph 21 of your witness statement, which for the transcript is page 4, no need to turn up, GBL, that's Gilberts, were provided with no information with regards to the new proposed system at Grenfell Tower. At the beginning of your examination, I think you mentioned that you often don't know the system you're asked to supply damper for. So
correct.
Does that mean this situation was typical for what Gilberts encounters?
Yes.
Do clients typically approach Gilberts to purchase a specific model of damper, or do they ask, can I have a fire damper? Can I have a fire and smoke damper? What do you have?
In relation to the Series 54 dampers, we would get asked for specifically either the Series 54 or a smoke evacuation damper. If they ask for a smoke control damper, we don't offer a smoke control damper. Therefore, we would say we don't offer one, but we do offer one of these. Is this what you're looking for? And point them in that direction. If the answer is yes, then we provide a quotation with a specification.
Thank you. And does Gilberts ever assist customers in selecting the appropriate damper from the range? From what the example you've given, sometimes they do. Is that right?
No. We don't assist in the product type. The product type would be reviewed and set upon by the customer. We may give advice as to regards something like the pressure drop or loss through the product, because there's graphs there. We may help out with the technical information relating to that if they asked. All the data's there, but it's a standalone product, and it's pretty simple in regards to if you're aware of the product type, then you'll be able to select from the brochure straight away.
Can I just ask you, you say that sometimes people come on to you and say, can you supply a smoke evacuation damper? Does that sometimes happen?
No one specifically asked me that question. We have an estimator specifically for the smoke and fire products.
Yes,
and the question could be asked.
I'm sorry. I'm now doing what I said you shouldn't do. What I was interested in to know is whether the expression a smoke evacuation damper was one that was widely used in the trade, so to speak. Do you know that one way or another?
Yeah, the smoke evacuation damper has existed for Gilberts for 10 years and been supplied into the trade for 10 years. So I'd assume by that the inference would be that it would be a known term and product.
Yeah, right. Thank you. Yes, sorry.
Thank you, Mr. Chairman. If the customer provides information to Gilberts and chooses a damper which Gilberts can see is clearly the wrong type for the system in question, is this something Gilberts will highlight to the potential customer or not?
Not specifically. We're not usually provided with that type of information. We don't deal with the smoke control systems. We're not advised of how they're going to operate in the building. You've heard of pressurization, depressurization, etc. That's never commented to us on how the product would be used during its intended usage.
In answer to my earlier question, you said that Gilberts doesn't supply the smoke control damper. Do I take it from that it didn't supply one in about 2015 either?
No.
And to the best of your knowledge, did other companies in around 2015, either in the UK or in the EU, supply smoke control dampers?
There are other dampers about. What their function, their test, and their detailing are, I couldn't be 100% certain of. There are choices of different type of product. For instance, you may move away from a damper completely and put a door in, if the system would allow you to do this. There are drawbacks to that in relation to a door would open on the floor to evacuate into a shaft and therefore not protect the shaft itself for someone falling through. The fire damper would obviously do that. So there are other different types of system that could possibly be utilised.
Thank you. In paragraph 18 of your witness statement, we don't need to go to it, you say no formal classification in respect to the dampers was sought by PSB or JSW, JS Wright, nor was any offered by Gilberts. To the best of your knowledge, did any Gilbert staff discuss the dampers certification or classification with PSB or Mr. Mahoney in particular, or anyone else involved in that project?
None whatsoever.
Is it unusual for a potential customer to offer no information about the system or not talk about certification at all and just specify a particular product, purchase it, and get on with it?
Yes, yeah. We would usually work, or our aim is to get our products in the marketplace. These are the grills and diffusers, fire dampers, all the arrangement of the products we produce, to be able to get the consultants to specify those up front, so that they then pass those to the contractors, who then said, can you now provide with those products and a price for those, please? That way we're first of our competition to be able to be given a price for the project.
Thank you, that's helpful. The next topic I'll turn to is the chronology of Gilbert's supply of the dampers to Grenfell Tower, and I'm going to go to paragraph 7 of your witness statement, please, which is again GBL 6010. To summarize, you say that Gilberts were first contacted by Mr. Mahoney of PSB requesting a quote from your colleague Mark Griffiths, an estimator.
Yes.
Did you, and you confirm you didn't have any involvement with this transaction personally?
Not personally.
Do you know what Mr. Griffiths and Mr. Mahoney discussed?
I've spoken with Mr. Griffiths to ask him the question, and as far as he was aware, he was just asked for to be able to provide a quotation for the Series 54 dampers.
So this was, as far as you're aware, this is one of the cases where a customer has a particular product in mind?
Yes.
Can we please now turn to the first quotation sent by Gilberts, which is GBL 706. Thank you. And we see from the date at the top right, 22nd of January 2015. Can we turn to page 3, please? And blow up the additional notes, so the second half of the page, please. And under the subheader, the Series 54, I'll read out, the Series 54 damper is designed to be used for natural and mechanical smoke extract applications by means of a vertical shaft. The damper has undergone an EN 13662 test, started from closed position, and lasted over 60 minutes for both fire integrity and smoke leakage, ES60, but has no formal certification. So this is different, isn't it, to the information we've seen in the 2011 brochure, which said fully tested to the requirements of EN 13666 Part 2 for 1 hour.
Yes, the brochure's gone through a number of iterations, and we have then updated the advice or the specification of the product from there.
And the particular difference is here it specifies it was tested from the closed position, which the significance of which we'll get onto, but it's significant, isn't it, in this context?
Yes, in the 2013 brochure, it was put in there to clarify to the customers that it was started from the closed position.
And again, clarifying, there's no formal certification. Are you able to assist why the inaccuracy in the 2011 brochure existed in the first place?
No, I've obviously read back, and the statement there, as we saw previously, was that it was fully tested to 13666-2. We went and I was involved in the fire test. We fully tested the damper through the full pressure regimes, the full time temperature curve of the furnace, etc. So the term fully means that we did the full test, in my opinion. I think that's why it was put there. I think that's what the brochure was leaning towards. Thank
you. Do you agree that the references here in the notes we've just read out to both integrity and smoke leakage performance suggest that the dampers were tested as fire and smoke dampers, not as fire dampers, although not formally certified? Yes,
the damper was tested and is always tested for insulation, smoke and integrity. But the certification would then come on the back of it. You would certify if, for instance, you failed the smoke leakage, you would then only certify to a integrity leakage.
So as far as, and please let me know if you don't know the answer to this, as far as the design intention behind the damper, was it intended to meet the requirements of a fire and smoke damper in terms of the 60 minutes smoke leakage criterion?
The integrity leakage for a 60-minute damper, yes.
But not the smoke leakage?
No.
So your evidence, as I understand it, is that's just the test that was done, the package of tests, but it wasn't that you were disappointed that it was submitted, it failed on that count because you never expected it to succeed. It wasn't designed for that purpose.
We knew it would not meet the 1,000 pascals ambient leakage anyway, due to the design of the product itself.
Does the absence of any formal classification or certification as indicated in this document therefore mean it's not certified even to the lowest of the 3 types of damper that we looked at?
Yes, it's a slightly long answer if I may. The product itself, the smoke evacuation damper, has no harmonised European standard that it can be tested or classified to. The other 3 are pigeonholed within there to be able to be tested to the harmonised European standard. And therefore can be certified. If you test to the standards that they're doing, you can still go ahead like we did and test the product to the standards and put it in a fire test to prove what would happen to the product over that duration and measure the different leakages. But you could obviously not certify it because the certification is only for the 3 categories listed.
Thank you. At paragraph 8, in fact, there is one further point to refer to on this page. Further down in the additional section, note section, this is the 3rd block of text from the bottom. It says, we strongly recommend that you discuss the specific technical requirements of the damper with the relevant authority to ensure that it is acceptable. Can you help us? What was the purpose of that note?
The purpose of the note is a follow-on from the answer I just gave, that the product is not a CE mark product. The reason for it is it has no harmonised European standard to be able to be CE marked under. So therefore, there was a construction product directive which changed to a construction product regulation in 2013, which then said that all the products put on the European market had to have a CE mark that had a harmonised European standard associated with it. That was a change at 2013 from a regulation to a directive, which meant it was mandatory now. It wasn't just advised. So that all of the fire dampers, fire smoke dampers and smoke control dampers fell under a harmonised system and would have to be CE marked. What we're saying here is that this falls outside of that system. There is no harmonised European standard, and therefore, if you want to use this product, you must get it checked because it has no formal CE marking. Not for the reason it doesn't want to have a formal CE marking, just the fact that it falls outside of the group of products listed within the harmonised standard.
So would you expect a customer wanting to install this damper in a, say, residential building to go off and consult building control to say, here's this damper, it's not CE marked, it's not certified, are we okay to use this?
Yes, that's what we'd expect. It's just my perception more than anything, I assume. Everything stops with building control. They seem to be the butt of everything as we move down the line, that we pass every responsibility down to building control and go, well, not me, ask building control, and if they say it's okay, we're all okay. I think that's just generally accepted in the industry, that we do have a checker, or if we needed to change away from a system, or a system couldn't be put within, you would need to get building control to check and sign off. And you would ask the expert of the building control to do that.
As far as you're aware, in respect to the Grenfell Inquiry project, from information you or the assessor estimator was given, was such a discussion ever discussed? Or was such a discussion going to take place, or did take place with building control?
We would have no.
You would have no idea.
We would have no reference to that.
Your witness statement, paragraph 8, again, don't need to go to. You say that after receiving this quote, Mr. Mahoney requested further information about the Series 54 damper, including test results, which were sent to him by email. Is that right?
That's correct.
Can we please go to that further information sent by Mr. Griffiths to Mr. Mahoney, which is at GBL 705 at page 2. This email doesn't have a date on it. Are you able to assist?
I am, sorry, yes. I saw the recording the other day and I noticed that myself, so I went back and checked. From memory, it was the 17th of March.
2015.
Yes.
Thank you, that's helpful. Do you have any record from either documents or your discussion with Mr. Griffiths about what prompted this exchange of emails or requests for test documents?
No, Mark had no recollection of any specific conversation and advised that he would have been asked to provide the testing documentation.
In your experience, typically, what would the purpose of providing such test results be? Is it for that ultimate check by building control, which you mentioned, or something else?
Not necessarily. The damper itself, because it isn't certified, would show what the actual leakage criteria of the product is. So whether it was 200, 250, 280, 360, it would actually show what leakage damper would perform at ambient closed leakage. This would then give the designer the ability to calculate how much air would be drawn through the shaft when the damper was closed on a non-fire floor. For example, if you had a 3-story building and the fire was on the ground floor, the dampers would open on the ground floor and evacuate the smoke. The other 2 sets of dampers on the other floors would close. You would then have a certain pressure, either naturally or via a fan, to then pull the air out of the shaft. What then happens is there will be some leakage negatively into the shaft from the damper. So in the other lobbies, there will be a small amount of air that will escape through the holes in the damper and up into the shaft. So that would then tell the designer how much leakage from the other floors there would be. So in the evidence previously around that they needed 3 meters cubed per hour, I think it was, for the open door leakage on the stairwell, what they would do is they would start with the 3 meters cubed per second and they would add leakage in of the specific damper that they'd chosen. So if they've chose our damper, they would be able to see from the graph provided to the size at what pressure drop the leakage would actually perform, which is in the page of the brochure itself, and then add those up so that it may be, for instance, 20 litres a second per damper, and then add those 20 litres a second to then add up to a total amount of air volume required, and then add on any extra leakage for any builder shaft leakage or anything else that they would have to take into consideration. But that's why we provide the specific data in the brochure, and that the test shows that as well.
Thank you. That's very helpful. So effectively, you provide the data to enable a building-based assessment of whether your damper is sufficient because it hasn't been certified within one of the categories. Is that a fair assumption?
That's correct.
Can we please now, I just turn the page over to the page 3, please. We see there an Exova fire resistance test conducted generally in accordance with BSEN 13662/1999 on a multi-blade damper assembly, dated 6th of October 2011. This probably goes without saying, given you've exhibited this to your witness statement, Mr. Jones, but I don't think it specifies anywhere the actual model. Is this for the Series 54?
Yes, it is. Yes.
Thank you. Can I ask you to turn to page 8? At the bottom there, instruction to test, the request of Gilberts as the sponsor, and Mr. R. Jones, along with 2 other gentlemen, were witnessing, and I assume that's you, yeah?
That's correct.
And turning over to page 44, please. In fact, Mr. Jones, I do apologize. One more question on that before I proceed. In addition to witnessing that test, what was your involvement, if any, with the Gilbert Series 54 specifically?
I was involved in the design of the product. Is that?
Yes, thank you.
Okay.
And the sheet we see here, is that an information data sheet for the actuator we saw a picture of earlier?
It is.
Thank you. Mr. Chairman,
Yes.
there is not a ready break coming up in the questioning, and given it's 11:15, this might be as good a time as any.
Just help us with this. How much longer do you think you might require with Mr. Jones. That's not meant to be a hint that you should get on with it at all. It's just that if you said only 15 minutes, we might postpone the break until a little later.
Yes. Thank you, Mr. Chairman. I do wish I was that concise, but not on this occasion, I'm afraid. It'll be a little longer than that.
That's all right. I just thought we might combine some breaks, but there we are. Mr. Jones, we have a break during each session. So I think we'll take the morning break now. We'll come back at 25 to 12. And while you're out of the room, I have to ask you, please, not to talk to anyone about your evidence or anything relating to it. Not that I think you'll have much opportunity to do so. All right, so if you'd like to go with the usher, we'll have you back at 25 to 12.
Thank you, Mr. Chairman.
Thank you very much. Thank you very much, Mr. Eustace. 25 to 12, please. Would you ask Mr. Jones to come back in, please? Right, Mr. Jones. I'm sorry we kept you waiting a bit longer than I suggested, but something had to be ironed out, and we're now ready to carry on if you are.
Yes, thank you.
Yes, Mr. Eustace.
Thank you, Mr. Chairman. Mr. Jones, before we return to the test results, I just want to pick up on something you said in answer to my question about the history of the Series 54 and the smoke evacuation damper. You said someone set the challenge to design such a damper, is that right?
Yes.
And who was that?
That was a general industry discussion, if you will. We've previously done the Series 50, 51, 52, 53, and now we're on to the iteration of the 54. So the history of the product is probably 20 years old. The start of it was that while my predecessor was involved with the Smoke Control Association, the question was asked, can you produce a damper that would do X, Y, and Z? It was up to Gilberts either to take the challenge up or not and go, sorry, we're not bothered, or yes, there will be a marketplace for it. It's worth us investing, putting the time and detail into the product to be able to make it a commercial viable product that the industry would purchase.
Thank you, I understand. Turning back to the Exova test report, so we were on GBL, it's 705. If we could go to page 8, please. That's the page setting out the test procedure. If we could zoom in on the second last paragraph in that section, introduction, prior to the fire test. Prior to the fire test being conducted and after establishing that the system leakage was lower than 12 cubic meters cubed per hour, the ambient temperature leakage of the damper was determined. In addition, the damper was subjected to 50 opening and closing cycles, after which the damper showed no signs of mechanical damage which could affect its operation. We discussed earlier the 10,200 required for a smoke control damper in certain circumstances, and it was 50, wasn't it, for the BS 13662?
Yes, correct.
And that's before actually applying the high temperatures for the fire test, you do that cycling test for 50 cycles.
The cycling test is nominated by the standard that you're working to. So if you wanted a smoke control damper, as you're indicating, you would have to get the 12101-8 smoke control damper standard, which states clearly you must test at least 10,000 cycles. Yes. Prior to doing the 13662 test, and then the 50 as well on top of that when you go to the fire test on the day.
Can we turn to page 42, please?
Can I just, sorry to interrupt you again, Mr.
Not at all.
My recollection is that you said earlier, when you were discussing the development of the testing of the 54 damper, that you would do your own cyclical tests, and I thought you said you would test it to destruction and then see how many cycles it achieved.
Absolutely correct. Yes, that's what we did. On the day of the test, we still had to test the damper 50 times, but we obviously didn't take the damper that we destroyed to the test. We took a new damper and then tested that 50 times and put that in. The original damper tested over 100,000 cycles, so it was 10 times more robust than would have been needed in the smoke control application.
All right. Thank you very much.
Thank you, Mr. Chairman. Page 42, please. And zooming in on the top box, please. Thank you. So that's the integrity leakage test, and the threshold there is 360. And summarizing what it says there, the test applied under pressure of 300 pascals plus minus 15. The specimen satisfied this criterion for the duration of 74 minutes, yes?
That's correct.
So that's, as again, 60 minutes required.
Yeah, as I mentioned before, the test was physically 74 minutes, but if you wanted to try and classify it, you could only classify it to every 15-minute slots or half-an-hour slots, depending on the standard.
Thank you. If we go right down to the smoke leakage section, so that's the S ladder classification, isn't it?
Yes.
Smoke leakage failure in accordance with the performance criterion of leakage is deemed to occur when leakage for the fire damper exceeds 200 cubic meters per hour, meter squared, measured after the first 5 minutes of the test duration. So there's an ambient leakage test beforehand, and then there is the first measure you take that counts is after 5 minutes.
Yes, if it fails the ambient leakage in the first place, then it's failed already.
Yes.
But they still report on this test anyway. So we already knew before this point that the damper would not achieve the final classification if it was to be classified.
Because it had failed the ambient.
The ambient leakage at 1,000 pascals.
And the test specified, again, the same pressure range. The specimen did not satisfy this criterion after the first 5 minutes of the test. But as you say, by this stage, it was all decided anyway.
I say it was not an aspiration for us at the time to achieve a smoke leakage for this type of damper. It was only to achieve an integrity, to give some form of integrity to the product, to be able to be put into a fire test.
Can I ask, why wasn't it an aspiration to make this damper as smoke-proof as you economically or practically could?
It would obviously be ideal to have no smoke leakage in any product in this situation, but to practically manufacture a product that would be subjected to a fire test such as this would be the fact that the furnace temperatures go from 0 to over 1,000 degrees within the hour. What you have is an expansion of product, and it being a metal product would expand at a specific rate for the material, therefore being a good number of millimetres expansion. What would happen then is during the fire test the blades would try and break out of the frame that were constricting it and therefore bow and bend and open up. The 300 pascals under pressure on the test would then allow that to bow into the plenum box away from the fire, away from the furnace as such, and that would cause even more leakage and therefore would fail the integrity test if, the smoke leakage test because the gaps would have been opening up at that point.
And if that's the case, is it then your evidence that there are no fire and smoke dampers on the market that have passed this quite rigorous, as you described, test, i.e. ES60 certified?
As far as I'm aware, there are products that are trying to achieve this standard. I haven't specifically witnessed or seen any fire test reports that show me that that's actually happened. The problem we have here isn't that we don't want to try and classify the product at all. The problem we have here is it's unclassifiable. So I have to make that distinction. It would be nice to be able to say that the smoke evacuation damper could be, but it doesn't have a standard that would suit the testing that it requires for its product usage. What I'm trying to say there is that the standard for the fire and smoke dampers, the smoke control dampers, and the fire dampers, for those tests, the test standard was written for those. There is an under pressure for those because there's a reason that you would have a pressure in a duct at a certain time that would then be needed to be defended against. Where you have the smoke evacuation dampers, you have them open on the fire floor, which means all the warm gases just trickle past and out into the shaft and wouldn't be subjected to the temperatures of the 1,000 degrees held within a piece of ductwork, for instance. The temperature of the duct behind would typically be about 100 degrees. This is just based on standard knowledge, if you will, from the industry. They say it gets to about 100 degrees as a throwaway temperature, just to give a guidance. What the fire test does is it goes up to 1,000 degrees at the back of this product, and then tries as well to pull off 300 pascals, an amount of air through the passages of the damper itself. So the actual usage of the product is very, very small in comparison to the test it's being put under. The test it's put under is an extremely rigorous test for fire and smoke and fire dampers and fire smoke dampers. This is a smoke evacuation damper, whereas if we were to set up a standard for it and a new test on its own to be able to get a harmonised European standard, then we would then have much different criteria to try and pass and fail against.
I understand what you're saying about achieving the certification, but setting aside the certification, was Gilberts trying to minimize the smoke leakage in this damper outside the certification process or not?
As much as it possibly could to achieve this pass rate for integrity. We had to take the damper to test, and we had to get some form of compliance that we could at least say, and the industry wanted us to be able to say, yes, you've managed to pass this onerous test, more than the damper would ever see in its lifetime or be expected to see, but at least you've managed to pass this test. And that was the point, that it had been treated and handled in an extreme way, that it could then be by the fire officers and the people designing the systems to say that smoke evacuation damper, I'm satisfied that it would be a life safety system and be able to be put into the building.
Thank you. Before the break, we looked at the quotation Gilbert sent to those involved in the Grenfell Tower project, which said the dampers lasted over 60 minutes of both fire integrity and smoke leakage, parentheses ES60, but had no formal certification. In light of your evidence and what we see on the page about the test, it's not right, is it, that it lasted for 60 minutes in terms of smoke leakage, ES60?
You're absolutely correct. Yes, that's an error.
And can you explain how this incorrect information came to be provided in both quotations sent in this case?
I assume the quotation was a copy and paste from the brochure. The brochure had indicated the fact that it was an ES60 as well. That's the conclusion I can come to. I've no evidence on that. But that's my best guess of how that occurred, and was used as a copy and paste note within the quotation. All those additional notes repeat themselves on all of our quotations. So that statement would be repeated.
Do you accept that could have a misleading effect on either the purchaser or, for example, building control, who might be reviewing those additional notes as part of their assessment?
Yes, that, I would accept that. What I would like to caveat that with, if I could, is the fact that no matter what we said in the brochure, the product that we provided was compliant with the Smoke Control Association guidance, recommendations and limitations from its inception.
Thank you. We will get to the SCA guidance, and you'll be able to give evidence on that. Paragraph 19 of your witness statement, I'm not going to read out in full, but you refer to sending a or rather, in addition to documents provided to Mr. Mahoney, you refer to a supplemental test document which was not provided, and you say that this report is a supplemental comfort test conducted to show that the damper, when open and subject to elevated temperature, would not collapse and would thus keep the damper airway clear. Yes? Can we see a copy of this report, please, at GIL 6014? In fact, I think that probably should be GBL, please, rather than GIL. I do apologize. It is GIL. I'm not quite sure why it is, but it is. Thank you very much. This is a 20-page test report from BM Trada dated 4th of October 2014. It's marked confidential and it says, we can see in the headline, a fire resistance test performed on a Series 54 smoke evacuation damper conducted using principles of EN 12101-2 2003 Annex G. Without looking through the entirety of the report, do you agree that this is not a report dealing with smoke leakage requirement?
It's not, no.
And so it doesn't in any way remedy the failure that was seen on the Exova report? Or the fact that the damper didn't pass the ASK criterion?
Yes, it's nothing to do with that whatsoever. This test is simply a test when the damper is in the open position, not the closed position, to prove that the damper would remain open on the fire floor while subjected to elevated temperature.
And the standard referred to here, the EN 12012, that concerns natural ventilators only and not mechanical extract systems, yes?
Again, because there is no set harmonised European standard that we can follow or test criteria for this product, it was in discussion with customers that they would prefer a comfort test, and this was suggested that we would go and have a comfort test to this standard. I therefore reviewed that and said, yes, I would think that would be appropriate, and they would be happy with me to be able to provide this evidence to them.
Are you able to assess why this document wasn't provided to PSB and JS Wright as part of this transaction?
As I said, the test, there would be no reason not to provide it. I don't know the exact conversation that Mark had with Mr. Mahoney, that they would have, he may have asked for the fire test report, and that was what was provided to him. Not either of the specific one or the two. He was just sent the fire test from the 13662 test.
Thank you. Now, again, going back to your witness statement, I will again summarize, if I may. Paragraphs 9 and 10, you explain that Gilberts provided some additional test information to Mr. Mahoney, and then another quote was requested for the same project, this time by J.S. Wright, and that quote was provided again by Mr. Griffiths on 6th of May 2015, yes?
Yes.
Do you have any more information than you've already given us about conversations or contact around that particular quote?
No, I've spoke with Mr. Griffiths and it was a standard email exchange which I've submitted that just asked for a quotation, and the quotation was provided.
And without going to the document, do you accept that quotation provided to J.S. Wright, which just for the transcript is GBL 709, contain the same additional notes we've looked at with the first one?
It did.
May we now please go to GBL 708? Page 2, please. It's a bit faint, but in the top right corner, we can see this as another edition, April 2015, of the brochure that we looked at before. So it's right, isn't it? By the time that this, by the time the May 2015 quote was provided with additional notes, this brochure was already in existence because it's April, yes?
Correct.
Can we turn to page 3, please? And top of the right column, if we may zoom in, please. We'll look at some revised wording here. The damper has undergone an EN 1366 Part 2 test started from closed position and lasted over 60 minutes for fire integrity, but has no formal certification. So is that an accurate summary?
Yes, this is the current as well as the 2015. It's still current today. The clarification was put in, and we added the testing that had been completed in 2014 to the documentation to say that we'd added that comfort test as well, and what that test provided with a B300 rating.
Are you able to assist why the quote we just talked about doesn't contain the updated information from this brochure?
As I said, the only thing I can think is it's a copy and paste issue in relation to the specific additional notes that are added. They're just standard format, if you will. Were incorrect in the first place and weren't corrected at the same time as the damper was corrected. Sorry, as the catalogue was corrected.
And in your answers earlier, you might have mentioned, I might be wrong, the 2013 brochure, is that right?
Yes, yes.
And what was the status? It's not a document, I believe, has been disclosed to the inquiry.
Yes, no, I've provided it to the inquiry.
And what was the text in the 2013 version?
I have it in the room, and I know you have it somewhere, but
was it has it been fully corrected as with the April 2015 version?
The major change I remember is that we added in the fact it was started from the closed position. The original brochure didn't mention it was started from the closed position. The 2013 confirmed it was started from the closed position, and then it's followed through here, the closed position.
Was the 2015 brochure we're looking at ever provided to JS Wright or PSB?
I'm not aware we specifically issued it to them, but it would have been available on the website from the date of April, sometime in April, when it was issued.
Are you able to say why it wasn't issued? Is that not a common practice?
It's just not a common practice.
Thank you. We will now go back to the Exova test, but only looking at some very limited specific issues. If we could go back to first go to BSEN 13662, which is BSI 50829, page 15, please. If we could zoom in on the bottom 2 paragraphs, please. This sets out the testing procedure for the fire test for fire and smoke dampers. Is that correct? or part of it?
I think so, yes. Yeah.
In the first step, set the fire damper into its open position. And on the following page, please. And see 10.4.3 with the fire damper fully open, and then some further steps. So was that one reason why, well, is that why the damper could not be said to be compliant with the this testing regime, because it was tested not from an open but from a closed position?
That would be a reason if you were trying to classify it to that. It's not able to be classified because it's not of that product grouping. So you can't classify it under the 13501-3 standard because it isn't one of the listed products in the three groups we're looking at of the fire dampers, smoke fire dampers and smoke control dampers.
Was there any other reason why you requested Exova to test from a closed position?
Yes, that's the normal expectation of the damper. It would be in a closed position and not subjected to elevated temperatures. Therefore, as I've mentioned, it's on the non-fire floors that the damper would be in the closed position, therefore receiving no heat at the start of any smoke signal or fire signal within the building. So therefore, in practice, that's where the damper would actually be positioned, in the closed position. And then we then tested the start from there. It would have been more onerous to start it from the open position because of expansion of materials. If the damper was open for a period of time, then what would happen is the damper blade could swell, the frame could swell, etc., and then we would have to watch out for more adjustments, if you will, of the damper product itself. So the safest way to test, if you will, from that point of view from Gilberts was, let's test it with it closed because that's its natural position.
So was there then a possibility that if tested from the open position, the swelling you described might have prevented the blades from operating as intended?
Absolutely correct, yes. The blades may not have been able to have fully closed and sealed, and therefore we wouldn't have got the integrity leakage that we were looking for, and therefore failed the test. At that point, the test would have been stopped and would have all wasted our time.
But in a system which I referred to earlier, where there's a joint environmental and smoke control system, which was the case at Grenfell Tower, where dampers might be in open position for environmental ventilation purposes. If a fire then begins, in those circumstances, you might have to close the damper in a way that involves increased temperature, yes?
I can answer the question in two parts. So the first is that the damper, when we first designed it and tested it, was designed not for any environmental. We weren't asked at the time to make it an environmental damper. So we made the evacuation damper as an evacuation damper from the closed position. If someone is deemed as a fire authority or a fire designer that they wanted to use this product, then again, that's up to them. They would be able to tell from the report that the motor, the actuator itself, would close full open and close cycle within a minute, as prescribed within the standard that it should do. Which means that if it was in the full open position, for instance, the worst it could be at that time, it would take 30 seconds to close as a maximum. Okay, so the fire engineer who designed, who wanted to know whether it was applicable for a ventilation system as well, would have to judge whether the temperature at the rear of the product on the non-fire floor would exceed a temperature relevant to the product within 30 seconds.
Would you recommend the installation of the Series 54 in a system that involved open dampers as a starting point, as a possibility?
Well, we've not tested it in that position. So my position is that I don't recommend that. What I would say is that it would be up to the individual designer to assess that and get an assessment. And again, I'll throw this back to the and check with building control, if that would be okay.
Thank you. If we go to paragraph 25 of your statement next, please. And again, I'll summarize. You refer here to the Series 54 damper meeting the cold leakage test at ambient temperature. And you refer to clause 8.2.1.5 of the Smoke Control Association guidance on smoke control to common escape routes 2015, which we'll go to shortly. Let's look first at that test result, if we may. If we go to the test report, GBL 705, please, page 5. Thank you. And that's the bottom box, isn't it, on the in the table? Leakage during ambient temperature test, 256.8. So that's over the 200, and that's a fail, as you said earlier,
For the S classification.
That classification.
Yes.
So can you explain briefly what the purpose of that test is, as distinct from the fire test element?
Could you rephrase that, sorry?
Yes. What is this? What is leakage during ambient temperature intended to test in a real-world situation?
How much the damper would leak in a cold situation. For instance, that if it was on a non-fire floor, and I explained before about the fan pulling a negative pressure into the shaft, it would then advise how much leakage off the non-fire floors would occur. And therefore you would then uprate your fan accordingly to account for that leakage.
And would the ambient temperature in this context include the increased temperature because of smoke rising through the shaft?
Not at this time, no. This is ambient, meaning it's at 20 degrees Celsius.
Yes. So as far as the utility of this measure for a real-world scenario where smoke is rising through a shaft and there's closed dampers on levels between that and the extract point, this wouldn't really give you much of an indication because the smoke there is much hotter, isn't it?
Yes, the reason that it's put there, as far as I'm aware, is again to advise the designer that at the test day that was the leakage of the product that occurred through there, so he could then do his own calculations from the testing at the ambient, or he could use the brochure for the pressure drop versus litre a second leakage through the damper.
Thank you.
Well, I think possibly the question may be whether the presence of hot smoke in the shaft would have any material effect on the leakage at ambient temperature, or leakage figure at ambient temperature.
That would be the leakage figure. You would then have to assess.
You then have so I'm sorry to interrupt you, but you then have, let's assume, the 20 degrees in the lobby outside and a hotter atmosphere on the inside. Would that affect the leakage?
Yes. If I can explain, I think you're all aware of the diagrams that Barbara Lane managed to put together, the pit storyboards. And if you can remember back, there's a little graph that she showed about the 200 metres cube per hour. There was a pass and fail line. And at the start, she started at the 258 up here. And after a short period of time, the damper expanded and sealed some of its own holes, therefore leaked less. And that dropped below the 200 metres cube per hour. That stayed there for about 50 minutes, I think, and then climbed back up into the zone under the 360 metres cube per hour. If you remember that diagram, that shows that as the product warms, then the leakage becomes less.
Right, thank you. Yes, Mr.
Thank you, Mr. Chairman. That would entail more smoke leakage than permitted during particular periods of that cumulative test, yes?
Sorry.
Yes, so as I understood what you were saying, Mr. Jones, that over the longer period, the average or cumulative smoke leakage would actually be lower than what's the certification requires.
Yes.
Yes. But during certain periods of that process, there would be significant, higher than peaks and troughs, I suppose. There would be some peaks during which more smoke would be coming through.
Yeah. When our damper was tested, it was shown to be that it would leak at 256 metres cube per hour ambient, which is over the 200 and below the 360. It then drops below 200 for the majority of the time of the first hour, and then falls out again at the very end of that hour period. So to its benefit, if you will, if it's warmer, then it leaks less.
I think we have to understand, we're not talking here, I think, if I've understood you correctly, about leakage of smoke out of the shaft. You're talking about leakage of air into the shaft, are you?
Yes.
Yes. Okay.
Thank you, Mr. Chairman. So yes, we're looking at the SCA Guide 2015 next, which is RBK 402932. Page 48, please. Thank you. And we're looking at item 3 at the top of the page, beginning of a fire damper. I think that's what you referred to in your witness statement, Mr. Jones, of a fire damper tested to EN 13662, but fitted with an on-off actuator and no fusible link. Ambient closed blade leakage should not exceed 360 at 300 Pascal, and this should be recorded in the test report. Do you want to tell us, please, what significance you attribute to this and how it applies to the Gilberts Series 54?
The Series 54 passed exactly that test.
Looking at the elements of that test, fire damper tested to EN 13662, because your damper, Gilbert's Series 54 damper, was not tested from open position, it therefore wasn't tested to EN 13662, was it?
It did undergo the test, the full test of the 362, but started from the closed position.
See, so your interpretation of a fire damper tested to that standard doesn't mean in accordance with all the conditions and standards and procedures of that standard?
I understand what you're saying, but the fire damper underwent that test, and we then confirmed that it was from the closed position.
Yes. I suggest that paragraph doesn't apply because the compliant procedure of EN 13662 wasn't undertaken during the Exova test.
The fire damper was tested to EN 366-2.
And the paragraphs, which we see 8 paragraphs below, in each case of the above, those 8 are conditions for any of the 3 paragraphs above to apply, is that right?
As I'm aware, yes.
Yep. And just looking at condition 4, if you can help us with this, when the product is deployed on the fire floor, it must open and remain open during the means of escape and firefighting mode. Do you see that?
Yes.
So the part which says it must open, what do you say that the Series 54 demonstrated that ability?
Yes, that's with the comfort test that we provided to prove that the product would open elevated temperatures.
See, but the comfort test we looked at was to do with natural ventilators, not mechanical smoke extraction system.
No, but it's a test that we used to prove the ability for the product to be open.
Thank you. Just one document, and this is an omission on my part. The 2013 brochure has been located, and I'll put it up now just so you don't have to go back to the room. I think it's GIL 6082. So we see August 2013 there. And can we go to the next page, please? And zoom in on the text at the top. The damper has undergone an EN 1366 Part 2 test started from the closed position and lasted over 60 minutes for both fire integrity and smoke leakage, but has no formal certification. So do you accept that the smoke leakage ES60 element is still inaccurate in this one?
That is inaccurate, and again the caveat is that it didn't actually matter because it was still in compliance with the Smoke Control Association guidance of 2012 and 2015.
Thank you. Lastly, we're going to look at some other testing issues briefly. And for that, if we could please go to Dr. Lane's report, BL ARP 25035 at page 233. And in fact, could we go back one page, please, just so we can see at the top? So 6.5.116. So Dr. Lane introduces the paragraph in the previous paragraph saying the only test evidence I've seen to date is one fire resistance test to BS EN 1366 and one fire resistance test to EN 12012. This is talking about the dampers, Gilbert's dampers. The significance of this is that, and if we could turn to the next page now, Thank you. The smoke control system used in Grenfell Tower incorporated a firefighter override, and therefore the position of the damper would have had to be changed 25 minutes into a BSEN 136610 test, whereas in 13662 test, the damper is closed within 2 minutes of the test starting and remains closed for the remainder of the test. The 136610 test is therefore more onerous in this regard because it requires it to move under higher temperatures. Do you accept that as a proposition?
Gently, yes.
Yes. And would you accept that it's important, if the damper is intended to be usable by firefighters in high temperatures via a manual override, that it is tested and can perform under these conditions?
I agree, yes.
And the BSEN 13662 procedure, therefore, wouldn't have tested whether these dampers could open again at a higher temperature.
Sorry, the Series 54 dampers that we provided?
Yes, Series 54.
Yes, were never tested or intended for that application.
The next document to turn to, please, is the RENA report, which is MET 3072161. Page 27, please. And we're looking at the final paragraph of the conclusion section at the bottom, please, if you could zoom in. In RENA's opinion, based on product information, the smoke damper actuators and the firefighters override switches, which are of course not a matter for you, Mr. Jones, were not designed to withstand exposure to the heat from an ongoing fire. As these units were exposed in the lift lobbies, it is likely that the system had not been designed to function reliably in a scenario where significant heat or fire were present in these areas. Do you agree with RENA that the damper actuators had not been designed to function reliably in such a scenario?
Not specifically, no. They'd undergone a test for an hour at elevated temperatures through a furnace time temperature controlled test. It depends on the expression of the extension of this from the ongoing fire. Is the ongoing fire, there's no heat time or exposure definitions there. So I'm struggling to just agree with the opinion.
It's too general in your view?
Yes.
Can you explain why the Gilberts dampers, as tested in October 2011, were not tested with an actuator to control the opening or closing movement? Is the answer simply that you weren't intending to open or close them at all in that test?
Correct.
And lastly, just a few questions arising from the evidence of Mr. Mahoney earlier this week. To the best of your knowledge, did Mr. Mahoney ask Gilberts about any other models or types of dampers?
No.
Did he ask about other dampers suitable for installation in a wall?
Not that I'm aware of.
And at that time, did Gilberts sell certified fire and smoke dampers? I think your answer earlier was that you're aware some other companies might sell something similar, but do we take it from that Gilberts didn't at the time?
Not suitable for walls.
Okay. And how significant a restriction is it that a damper has to be installed in a wall? How far does that narrow your range of available dampers?
The smoke dampers, fire dampers, could all be placed in walls under certain fixing conditions and are tested as such under 13662 regime for that. So they can all undergo those tests.
See, so just because you have a duct in a wall doesn't mean you can't install any damper in it, is that right?
It would have to be the damper suitable for how the damper was tested in the condition that it was tested. If it was tested in a wall, then he could use that damper in a wall situation.
Thank you, Mr. Jones. Just a final question. Given that the Series 54 damper failed the smoke leakage requirement, can you explain in what kind of scenario you anticipated being used in a smoke control system?
Yes, the reason for the product and the design was that it would be put into a building. It would be put onto the fire floors or all the floors of the building and be used as a smoke evacuation damper, so that when there was a fire on the floor of any one of the floors, the trigger would be that a smoke control system would identify that floor and open that damper to allow the smoke and any gases on that floor to be evacuated through the shaft system, be it natural or mechanical. The dampers on all of the other floors would remain closed.
And as far as smoke leakage through the dampers on those other floors, so the closed dampers, does the failure or the non-certification of the smoke leakage condition not compromise their ability in practice to protect people on the other side from smoke?
Not at all, no. The shafts are under negative pressure, so the smoke's going up the shaft, not onto the non-fire floors. The leakage is drawing air off of the non-fire floors and up the shaft and away. The only compromise there may be is that you have to design the fan or the exhaust system, the natural ventilators, to be able to pull and add that factor as your overall air volume to make sure that the fire floor is serviced correctly and the right amount of air is pulled off the fire floor.
And that depends on the fans functioning.
Yes,
the
but
negative pressure.
yeah, in this instance, there's a fan system. It could be a natural ventilator. It could just be a shaft up a building.
Thank you, Mr. Chairman. Those are all the prepared questions I had. May I suggest 10-minute break for any final questions?
Very well. Well, Mr. Jones, when counsel gets to the end of his questions, we always have a short break to give him time to check that he hasn't left anything out, and also to allow others who are not present in the room to suggest questions that possibly we should put to you. So we'll break now for 10 minutes. I'm going to say 12:30. We may find we need a little longer, but if we do, there it is. No. And then we'll see whether there are more questions for you. Okay. All right? Thank you very much. And please don't talk to anyone about your evidence.
Of course.
Thank you. Right, I'm going to say 12:30, but slightly less than 10 minutes. If you need more time, just let us know.
Thank you, Mr. Chairman. Thank you.
would you ask Mr. Jones to come back in, please? Right, Mr. Jones, we'll see if there are any more questions for you. Yes, Mr. Eustace.
Thank you for the time, Mr. Chairman. There are no further questions.
Well, very good. Thank you very much.
Thank you.
Well then, Mr. Jones, I think it only remains for me to thank you very much on behalf of all three of us on the panel for coming to give us your evidence. I think I can speak for all of us when I say we found it very interesting and very informative. And we're very grateful to you for coming all the way from Blackpool, which I imagine is where you started,
Sure.
to give us your time and tell us all about it.
Yes.
Thank you very much,
Yes.
and that's all we have for you.
Thanks for the opportunity. Thank you.
Yes, and Ms. Eustace, I think we have another witness waiting for us, don't we?
Yes, Mr. Crossmith, I'm going to do a very quick swap with Ms. Gray.
Well, we need to rise for a short moment just to enable the arrangements to be made. So we'll do that, and we'll come back in as soon as the usher comes to tell us you're ready for us.
Thank you.
Thank you. Yes, Ms Grange.
Yes, Mr Chairman, could we have our next witness now, please? Mr Matt Cross-Smith.
Yes, thank you. Good morning, Mr Cross-Smith. I understand you're going to make the affirmation.
I am, yes.
Could you please then read the words on the screen?
I do solemnly, sincerely and truly declare and affirm that the evidence I shall give shall be the truth, the whole truth and nothing but the truth.
Good. Thank you very much. Please sit down. Make yourself comfortable. All right?
Yep.
Good. Yes, Ms Grange, when you're ready.
Yes, thank you. Can you give the inquiry your full name, please?
Yeah, it's Matthew Cross-Smith.
Thank you. And thank you very much for coming to assist the inquiry today with its investigations. It's very much appreciated.
Okay.
I'm going to be asking you the questions today. If you have any difficulty understanding anything I ask, please just ask me to repeat the question or put the point in a different way. And if you can try and keep your voice slow enough that the transcriber sitting to your right can take a nice clear note, that would be great.
Yes.
Now, you've made one witness statement for the inquiry. If we can go to it, it's at MAX 30-17304. There we have it. We can see the date, 9th of October 2018, in that top right-hand side. If we go on to page 28, there we can see the date again. And is that your signature?
It is.
And have you read your statement recently?
I have.
And can you confirm that the contents are true to the best of your knowledge and belief?
I can.
Thank you. And have you discussed the evidence you're going to give today with anyone before coming here?
No.
Thank you. Now, I'm going to start by asking you some questions about your background and your qualifications and experience. And you've helpfully set out your qualifications for us at paragraph 2 of your statement. If we go to that on page 1, and you tell us there that you're a chartered building services engineer with a master's degree in mechanical and automotive engineering. You joined Max Fordham in May 2012 following 2 years in an engineering role at Jaguar Land Rover, and your title at the time was graduate engineer. And then you go on to explain that during your time at Max Fordham you became a chartered engineer of the Institute of Mechanical Engineers in February 2015 and then a partner in May 2016. Is that correct?
That is correct.
And you also go on to tell us that you left Max Fordham in July 2016, although you continued to do some consultancy work for them until around September 2016. Is that correct?
That is correct.
And do you continue to work as a building services engineer?
I work in the same field, yes.
Yes, thank you. And to what extent did any of the training that you received, as you've summarised there, relate at all to smoke control systems?
Not directly, no.
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 Yeah. And if we can go to paragraph 3 of your statement, you tell us there that Max Fordham is a building services engineering firm providing services in the areas of electrical, mechanical, plumbing, building physics, lighting and acoustic design. So there we have the kind of overall remit of Max Fordham as a firm. To what extent did your role while working at Max Fordham involve working on fire safety systems?
Only in so much as it touched this particular project.
I see, yeah. So was this the only smoke control project as well that you were involved in for Max Fordham?
Yes.
Yes. And prior to working on the project at Grenfell Tower, had you been involved in any projects at all in any capacity which had involved the design or installation of a smoke control system?
I started Grenfell Tower in, I believe, the first week that I joined Max Fordham.
Yes.
So no.
No, thank you. Now, if we look at paragraph 4 of your statement now, you explain that Max Fordham's involvement in the Grenfell Tower project began shortly before you joined the practice, and you joined in late May 2012. And as you've just said, you were assigned to work on it during your first week. And is it right that you worked on the Grenfell project for the whole time that you were with Max Fordham up until you left in July 2016?
Yes, there was a pause of 6 to 12 months, I believe, between Reba stages D and then the production of our employers' requirements, but generally on and off throughout that period, yes.
Yes, thank you. And would it be right to say, and I'm now summarising your evidence at paragraphs 4 and 5 of your statement, that when you began working on the Grenfell Tower project, you were working under the direction of Mr. Andrew McQuat, the project engineer? Is that correct?
That is correct.
Yes, and we've heard from him previously in Module 1 of the inquiry's work. And is it also right, was it your understanding, that when Max Fordham first started working on the Grenfell project, this was on the understanding that the TMO's intention was to have the same team of contractors working for them as had worked on the CALC, the Kensington Academy and Leisure Centre project?
That was the original intention, correct?
Yes,
Yeah.
which had included Max Fordham. Yes.
Correct.
Now, at paragraph 5 of your statement on page 2, you go on to describe how your role in the Grenfell project developed. And you explain that around the time that Ledbetter left the project, you became involved. So, picking it up in the 4th line, you say around May 2013, Ledbetter left the project. During approximately the same period, internally, the project moved down to the London office of Max Fordham, and Duncan Campbell took over as senior partner. My involvement increased, and I became the main point of contact for the TMO. I would typically deal with the day-to-day issues, consulting with Duncan as required on technical details and reviews, while Duncan would deal with contractual issues, such as the scope of our appointment and fees. Duncan and I together produced the employer's requirements for the services, and following the appointment of Ryden, I carried out some visits to site, witnessed some of the commissioning, and attended some site meetings as required under our contract. I left the project when I left Max Fordham in July 2016, shortly before the award of practical completion. So that's a nice, neat summary of the development of your role on the project. Is that correct?
That is correct.
And how often were you on site at Grenfell Tower as part of that role?
So initially during the early design stages, so from prior to the appointment of the general contractor, we were on site as required for inspections to understand the existing systems.
Yeah.
I would say maybe approximately once a month.
Yes.
Of that sort of order. And then after the award to the general contractor, we were then contracted for 12 site visits during the period from that point through to completion of the project.
Yes.
So I believe we stuck pretty much to that 12.
Yes, I see. And those site visits you were then reporting back to your client, who remained the TMO, yes?
Correct.
Yes, so you were client side throughout.
Yes, we were retained by the client as an advisor.
Yes.
The majority of the rest of the design team were novated directly to the contractor.
Yes, thank you, that's helpful. Now, if we look at paragraph 6 of your statement on page 2, you tell us what were the primary objectives of the project, and you say that they were to, as far as Max Fordham were concerned, they were to replace the inefficient heating and hot water system, to improve the thermal efficiency of Grenfell Tower, and to tackle an existing overheating issue within the tower. Now, is it right to say that the smoke control system was a secondary aspect of the project?
The smoke control system was not initially part of the scope of the project.
Yes.
It entered the scope at a later date, just prior to our issue of our Stage C report, I believe. But when it did enter the project, it was equally important to all other aspects of it.
Yes, thank you, that's helpful. Now, just carrying on with your involvement with the system at Grenfell Tower, if we go to paragraph 29 of your statement now on page 11, and looking at the specific work that you did in relation to the smoke control system, you tell us this. You say that Max Fordham was responsible for developing the design up to stage D, writing the employer's requirements for the system to be further developed by the contractor. So that would be Ryden, yes?
Correct.
And was involved in assisting the architect and employer's agent in discussions with building control on proposed strategy prior to detailed design by the contractor. Is that correct?
That is correct.
So where you talk about the architect, that would be Studio E, and would it be Artelia, the employer's agent?
Yeah, initially Apple Yards, and then they changed their name to Artelia.
Yes.
Same company.
And then you say the fire strategy, including setting out which areas were required to be served by the SVS, that's smoke ventilation system, yes?
Correct.
And overall design principle of the system was set by the fire engineer ex over. So is it right that in general terms, Max Fordham carried out some initial design work for the smoke control system, including writing a section for that in the employer's requirements that are then tendered out, and that was intended for then a more specialist contractor to develop further? Is that a fair summary?
That is a fair summary, correct.
Yeah. And was it always envisaged that a more specialist smoke control contractor would be engaged at some stage down the line to develop the initial design work that you did?
That was certainly our recommendation.
Yes, and who did you make that recommendation to?
I believe we made that recommendation to the contractor at the point where the contract was awarded to Ryden.
Yes, I see. So you recommended to them at that point that they needed to get a specialist smoke control system designer on board to develop the design, is that correct?
Yes, we introduced the contractor Ryden, I believe Simon Lawrence at Ryden, to PSB, who we had been speaking with up to that point.
Yes. And we'll come to it in a moment, and it's right, isn't it, that when you were writing the employer's requirements, you were taking some initial advice from PSB?
Correct, advice from PSB and also from Exover, the fire engineer.
Yes, thank you. Yes, now, just some brief questions about the regulatory requirements which applied to the refurbished smoke control system at Grenfell Tower. Did you yourself ever have cause to consider what the functional requirements were of the building regulations, certainly in relation to fire safety, that you were designing the system for? Did you ever apply your mind to that?
Yes.
And what were those functional requirements that you were designing the system to meet?
Those were as laid out in approved document B.
Yes. So would that have included functional requirement B1 on means of escape?
Correct.
Which provides that the building should be designed so there's appropriate means of escape in case of fire, yes?
Correct, although also to be noted, this was a refurbishment project.
Yes.
So there was within the building regulations, there is a provision within there for a refurbishment project to make an existing situation no worse than it is currently is.
Yes, I understand. You're talking about the non-worsening. Yes.
Correct.
But in just in terms of what you were to make not worse, it's the functional requirements you have to make not worse. That's correct, isn't it?
It's the performance of the existing system relative to the functional requirements.
Yes.
Correct,
Thank
yeah.
you. Yes. And again, another relevant functional requirement would be requirement B5, wouldn't it? The design and construction so as to provide reasonable facilities to assist firefighters.
Correct.
Yeah. And what about B3? That's functional requirement B3 on internal fire spread, which requires consideration of, for example, compartmentation and smoke spread within the building. Did you have that in mind when you were carrying out your preliminary design work?
B3 was certainly referenced. We would reference B1, B3 and B5 typically as building services engineers.
Yes.
So yes, we would have referred to that.
Yes, thank you. And to what extent, when you began developing the proposals for the smoke control system at Grenfell Tower, to what extent did you have a look at the guidance that there was in approved document B on fire safety?
I mean, I reviewed the relevant sections of approved document B at the time.
You did?
Yes.
Yes. Just let's quickly remind ourselves, if we go to approved document B, which is at CLG 50224, and if we go within this is the addition that would have applied at Grenfell Tower. If we go within that to page 31, we can see actually it begins on the, perhaps we ought to pick it up the page before, 30. At 2.2.5 we get a section on smoke control of common escape routes, and it makes clear there, despite the provisions described in this approved document, it is probable that some smoke will get into a common corridor or lobby from a fire in a flat, if only because the entrance door will be opened when the occupants escape. And then over the page, there should therefore be some means of ventilating the common corridors, lobbies, to control smoke and so protect the common stairs. This offers additional protection to that provided by the fire doors to the stair. And then in parentheses it says the ventilation also affords some protection to the corridors and lobbies. Now, can you recall being aware of these provisions within approved document B?
Yes.
Yes. And we can see that it goes on. It says this can be achieved by either natural means in accordance with paragraph 2.26 or by means of mechanical ventilation as described in paragraph 2.27. So were you aware that there were, in approved document B, it just distinguishes between these two types of systems, a natural smoke ventilation system and a mechanical smoke ventilation system? You were
Yes.
aware of that? Yes. And at 2.27, we can see it says, as an alternative to the natural ventilation provisions in 2.26, mechanical ventilation to the stair and or corridor lobby may be provided to protect the stairs from smoke, and that guidance on the design of smoke control systems using pressure differentials is available in that British Standard BSEN 12101, Part 6, 2005. Did you ever, we'll come on to it later, did you ever have a look at that British Standard? It's the only British Standard that's mentioned there in relation to mechanical ventilation systems.
I did.
Yes. And did you read it at the time you were working on the Grenfell
Yes.
project? Yes, thank
Yes.
you. Now, just having a look at something within that British Standard for a moment, if we could go to RBK 45054. This is that British Standard. It contains a specification for pressure differential systems. And at page 57, at section 9.1 at the bottom, it explains what the objective of a depressurisation system is. And 3 lines into that, it says it is important to note that there's no protection of any part of an escape route within the depressurised space itself, which may be entirely filled with smoke, or may even be fully involved in a fire. This constitutes a fundamental difference between depressurisation and smoke exhaust ventilation. Do you see that there? Now, do you remember being aware of the differences that this guidance was drawing between smoke exhaust ventilation systems and depressurisation systems? Did you yourself ever have to grapple with that?
I don't recall personally
Yeah.
grappling with that. I believe we were reliant somewhat on the advice from Exover as fire engineer and PSB as specialist designers in order to steer us towards the most appropriate measure.
Yes, I understand. Thank you. And just let's look at another British Standard for a moment, just briefly. This is BS 9991 2011. If we could go to that at BSI 50621. This is a British Standard publication, Fire Safety in the Design, Management and Use of Residential Buildings Code of Practice. Do you remember ever consulting this code of practice as part of your preliminary design work?
Yes, I do.
Yes. And if we go to page 73 of this, at paragraph 26.2.5, in the second paragraph down, we can see it says a mechanical smoke ventilation system should demonstrate equivalent or better conditions in the lobby or corridor and stairs than the natural ventilation system that it replaces. Do you see that?
I see that.
And were you aware of that piece of guidance and that principle when you were looking at the Grenfell Tower system?
I can't recall whether I was aware of it at the time. I think I would probably have made that assumption regardless of being aware of that guidance
Yes, I understand. And then at note 1 below, we can see that it says this is usually shown by a comparative computational fluid dynamics analysis, and that's sometimes referred to as a CFD analysis, isn't it?
It is, yeah.
And can you just help us in very brief terms, what is a CFD analysis?
It's basically a computer simulation of the movement of a fluid, in this case, a gas, and an understanding of how that gas would behave in certain conditions. And those conditions are typically include, either movement through pipes or movement within a plenum or a volume.
Yes, thank you. And was CFD analysis something you became familiar with as you started working for Max Fordham?
I never undertook any CFD analysis whilst at Max Fordham.
I see. Were you aware that this guidance makes clear that for a mechanical smoke ventilation system, showing that it was equivalent or better than any natural system it replaced was usually shown by a CFD analysis? Were you aware of that?
Again, I don't recall whether... I don't believe I was aware from this specific document. I think I would typically have been aware that CFD would be one way of demonstrating how smoke moves for fire engineering purposes.
Yes, and there would be other ways that you could demonstrate that as well, wouldn't there?
Yeah, yes, there are other ways.
Yeah, including possibly just calculations, hand calculations, is that correct?
It's correct, but it would depend upon the complexity of the situation that you were looking at as to what the relative accuracy may be.
Yes, thank you. Now, did you ever come to look at something called the Smoke Control Association guidance during the time you worked on the project?
I don't recall referring to that.
No. So, does it follow that you didn't understand at the time that where an alternative solution is being adopted for smoke control outside the prescriptive methods that we see in, say, the British Standard we looked at before, 12101 Part 6, did you not understand that the SCA guidance recommends that there should be a method agreed by which you're going to assess its performance? Was that something that was ever discussed?
As I just said, I wasn't aware. I didn't refer to the SCA guidance at the time. So if that specific wording is within that, then I wouldn't have been aware of it.
I understand. So nobody on the project ever discussed the provisions of the SCA guidance. Is that fair in terms of with you?
With me personally?
Yeah.
No, but obviously I can't speak for
Yes, I understand.
others.
I understand. That's helpful. Mr. Chairman, I think that's a good moment to pause and take our lunchtime break.
Thank you. So do I, yes. Well, Mr. Crossmith, I've only just got into the witness box, but now I'm forever going to send you out again because I think we'll have a break for everyone to have some lunch. We'll resume at 2 o'clock, please. And I say this to all witnesses, please don't talk to anyone about your evidence or anything relating to it over the break. All right?
Okay.
Thank you very much. Would you like to go with the usher then, please?
Thank you.
Thank you very much. 2 o'clock then, please.
Thank you.
Thank you.